Okay, this is part 2 of 10.3. This was broken up on purpose because these last two problems are going to be a little bit long. What we're doing is we're looking for complex roots. Remember that roots are solutions. Let W equal R cosine theta plus I sine theta be a complex number, and let n be greater than or equal to 2 be an integer. If W does not equal 0, there are n distinct complex nth roots of W given by the formula z sub k equals the nth root of R times cosine of theta over n plus 2k pi n over n plus I sine theta over n plus 2k pi over n, where k equals 0, 1, 2, n minus 1. What we're going to be doing is we're going to have to come up with a formula by using this particular formula, and then we're going to be plugging in for k. Okay, and I also want you to notice that our values have to be in polar form. So let's go ahead and look at this first example. I'm going to write some of it on this page, and then I hope that I did. I left room on the next page. So let's start on this. Find the complex cube root of -1 plus 3i. Leave your answer in polar form. Well, first of all, this is not in polar form. This is in rectangular form, where x equals -1 and y equals radical 3i. Complex cube root, the reason why I highlighted that is because n equals 3. So n equals 3. So the first thing we have to do is change -1 plus 3i to polar form to be able to use the formula to find the complex roots. So to find something in polar form, we got to find r first. And if you remember, r is the square root of x squared plus y squared. So if I plug in my values, I get -1 squared plus radical 3 squared underneath that. So what do I get? I get 1 plus 3, which equals square root of 4, which equals 2. So I know that r equals 2. All right, we also need theta. So remember that theta is the inverse tangent of y over x. So if I plug that in, y is radical 3 over x, which is -1. Okay, so when we do that, we get negative radical 3. So therefore, I can use my 30, 60, 90 triangles, which I'll place over here. 1, 2, radical 3. So radical 3 over 1, that's going to correspond to a 60-degree angle. But remember, we have a negative value. So the negative value for theta, we can plug it in, but then we're going to have to take care of it. So let's plug it in and see what happens. So in polar form is r times cosine theta plus I sine theta. So plugging this stuff in, I get 2 times cosine of negative 60 degrees plus I sine of negative 60 degrees. Okay, I got to apply the even odd. So cosine's even, sine is odd. So I get 2 times cosine of 60 degrees minus sine of 60 degrees. Okay, now I'm in polar form, and now I can use my formula. So that's the next step. Alright, so I'm plugging this into the equation, and I'm going to use the page here. So the equation is z sub k equals the nth root of r times cosine of theta over n plus 2 pi over nk plus I sine of theta over n plus 2 pi over nk. Okay, so I have the information. Now I'm going to start plugging some things in. So the nth root, remember n equals 3. We're going to start plugging some stuff in. So we have the cube root of r, where r we found out to be 2, times cosine of the angle. Remember the angle was 60 degrees, and we're going to divide that by 3, plus 2 pi over 3k, plus I sine of 60 degrees over 3 plus 2 pi over 3k. And remember, I had to apply the even odds, so this actually is negative. So let me fix that really quick. So there's a negative sign right there. Okay, so I'm trying to come up with this generic formula so that way I can plug in k equals 0, k equals 1, etc. So this becomes the cube root of 2 cosine, when I divide 60 divided by 3, I get 20 degrees, plus, remember that 2 pi over 3 is equivalent to 120 degrees. I'm going to leave it as 120k because it'll be easier to plug in. And then sine is going to be the same thing, 20 degrees plus 120k. All right. So now that I have everything ready to go, I have my generic formula. This is my generic formula. I now need to plug in k's to find the roots. So let's let k equal 0. And by the way, if there's a cube root, I should have 3 answers. Okay, so let's plug in k equals 0. If I plug in k equals 0, I get the cube root of 2 cosine of 20 degrees plus 120 times 0 minus I sine of 20 degrees plus 120 degrees times 0. Okay, I know the 120 degrees times 0, those are going to go away. So what am I left with? I'm left with a cube root of 2 times cosine of 20 degrees minus I sine of 20 degrees. And this is my answer. So there's a first answer. Now remember, we're supposed to have 3. So let's let k equal 1. So I'm going to plug that in next. K equals 1. So it's going to be the cube root of 2 times cosine of 20 degrees plus, and I'm using my generic formula, 120 degrees times 1 minus I sine of 20 degrees plus 120 degrees times 1. So once again, I plugged it into the general formula. Okay, so I get the cube root of 2, cosine 120 degrees times 1 is 120, 120 plus 20 is 140. Okay, and then sine is going to be the same value. Okay, so you just found your second answer. So let me highlight that. That's my second answer. So I'm looking for one more. K equals 2. So once again, plug in wherever you see k into the generic formula. You're going to plug in 2. So this becomes cosine of 20 degrees plus 120 times 2 minus I sine of 20 degrees plus 120 degrees times 2. So once again, I plugged into the generic formula. Okay, what's my answer? Cube root of 2, cosine of 120 times 2 is 240. So 240 plus 20 is going to give me 260 minus I sine of the same thing, 260. Okay, and that is my third answer. Now listen, how do I know when to stop plugging in for k? If I let k equal 3, remember I'm taking 120 degrees and multiplying that by whatever k is. So if k is 3, I get 360. And remember, I have to add 20 to that. So 20 plus 360 exceeds the limit. The limit is 2 pi, which is 360. So going beyond that doesn't work. Okay, so I have my 3 answers. Answer number 1 is the cube root of 2 times cosine of 20 degrees minus I sine of 20 degrees. I have answer number 2, which is the cube root of 2 cosine of 140 minus I sine of 140. And then finally, answer number 3, the cube root of 2 cosine of 260 degrees minus I sine of 260 degrees. So those are my z's, or my complex cube roots. Okay, let's try another one of these. So find all the complex roots, leave your answer in polar form with the argument in degrees. The complex cube root of 6 radical 3 plus 6i. So once again, it's complex cube roots. So we know that right away n equals 3. Okay, and this is in rectangular form, so I have x and I have y. So first things first, we have to write this value in polar form. So once again, we have to find r, and r is the square root of x squared plus y squared. So 6 radical 3 squared plus y, which is 6 squared. When I do that, I get square root of 36 times 3 plus 36. Okay, and 36 times 3 will give me 108 plus 36. You get 144. So this one works out nice because r equals 12. Okay, we also need theta. So theta is equal to the inverse tangent of y over x. So if I plug and play, I get inverse tangent of y, which is 6 over 6 radical 3. The 6's cancel. So I'm looking for 1 over radical 3. If I look to the triangle, 30, 60, 90, I will see that I'm looking for opposite over adjacent. What angle works with that? 60 degrees. Oops, I lied to you. Correction, it is not 60 degrees, it's actually 30 degrees. So 30 degrees is opposite over adjacent. So theta equals 30 degrees. There we go. Okay, be careful, because if you mess up at the beginning, throw this whole thing off. So polar form. Okay, remember it's r, which is 12, times cosine of theta, which is 30 in this case, plus I sine of 30 degrees. Now we didn't have to apply even odd because we had positive values in there. Okay, now I'm ready to use a formula. What's the formula? The formula is z equals the nth root of r times cosine of theta over n plus 2 pi over nk plus I sine of theta over n plus 2 pi over nk. Alright, so let's plug and chug. So n is 3. The radius is 12. Cosine of the angle is 30 degrees. And we're going to divide that by 3 because that's what n is. Plus 2 pi over 3k. Plus I sine of the same thing. So 30 degrees over 3 plus 2 pi over 3k. Okay. 2 pi over 3, remember, once again, that's 120 degrees. So the general formula is going to be the cube root of 12 cosine of 10 degrees plus 120k plus I sine of 10 degrees plus 120k. Alright, so same business as before. This is the general formula. Now we're going to use it to actually find the k's. So once again, start at k equals 0. So if I plug in k equals 0, I get the cube root of 12 cosine of 10 degrees. Now 120 times 0 zeroes out. plus I sine of 10 degrees. Because once again, 120 times k zeroes out. Okay, so that's my answer number 1. Okay. K equals 1. So the cube root of 12 times cosine of 10 degrees plus 120 degrees times 1 plus I sine of 10 degrees plus 120 degrees times 1. Okay, we know 120 degrees times 1 is 120. 120 plus 10 will give me cosine of 130 degrees plus I sine of 130 degrees. And then we're going to multiply that by the cube root of 12. So this is answer number 2. Okay. All right, let's do k equals 2. So I get the cube root of 12, cosine of 10 degrees plus 120 times 2, plus I sine of 10 degrees plus 120 times 2. Okay, so 120 times 2 is 240. So if I add 10 to 240, I get 250. So this becomes the cube root of 12 cosine of 250 plus I sine of 250 degrees. And that is your last answer. That's answer number 3. And I know I'm done because if I let k equal 3, remember I'm multiplying that by 120. So 120 times 3 is 360, and then you add 10, you're beyond your border, which is 2 pi, or 360 degrees. So that's how I know I'm done. So I found all k's, answer 1, answer 2, and answer 3, and I am done. So 10.3 is finished.